Good morning, everyone. It's Friday the 13th, but it is your lucky day because you have the chance to see a webinar dedicated to utilization of drones for crop protection. Thank you for joining us. My name is Markéta Kolerová. I am from the Plan for All organization, and I will be your host. The webinar today is organized as a part of the ongoing Agrihub INSPIRE Hackathon 2022, which is open for everyone. So if you want to be part of the hackathon community, you are more than welcome to join us. Today, we will focus on challenge number 15, called Utilization of Drones for Crop Protection. You will see 3 presentations. The first one will be an introduction of the experiment itself, presented by Professor Zuzana Balková from the Slovak University of Agriculture in Nitra. Second part will take you to the world of robots and drones and their specific utilization in agriculture. This will be presented by Dr. Patrik Kosa, also from the Slovak University of Agriculture. And the last part will be presented by Dr. Roman Danel from the Technical Universities of Ostrava and České Budějovice and University of Economy in Bydgoszcz, who will speak about the competencies of universities and their students for the use of drones in agriculture. Some technical information before we start. The webinar is recorded. The recording will be sent to your registered emails. If you have any questions to our speakers, you can either use the chat box or you can speak up after the presentations. But for now, please keep your microphones muted. Thank you. And now it's about time to introduce the first speaker, Professor Zuzana Balková from the Slovak University of Agriculture in Nitra, whose main research interests include digital technologies, modeling and simulation of processes in agriculture, or, for example, application of digital technologies to education. So, Zuzana, you may start with your presentation.
Thank you very much, Markétka. Sorry. It's my pleasure to be here in Agrihub INSPIRE Hackathon 2022 and give you some information about the Experiment 6, which is part of the project Agrihub Czech and Slovakia. And this is the project which is subcontract of the Horizon Digital Innovation Hub project, Smart Agrihub. And I hope that this presentation will bring you more information about the activities that have been done and will be done in the frame of the Innovative Experiment 6 in this project. So I try to share my presentation, and as I mentioned, that the Innovative Experiment 6 is a part of the project Agrihub Czech and Slovak Republic, and it is the challenge number 6, drone utilization for crop protection storage capacity. What was the problem behind this innovative experiment is the problem that good health and nutrition condition of crops in agricultural area in general, missing automatic decision support systems, and together with the fact that the drones are very popular now in the field of, not only in the field of agricultural, but also in any other sectors of industry. So we decided to create automatic decision support system that will allow to measure and collect data from the purpose of the precision application of chemicals and water, according to the information from the data that can be collected from the drones or from the using the Agrihub tools and data sets that will bring that will also help to identify the health status and the nutritional conditions of the crops. So what we set up as a challenge at the beginning of the project or of this experiment. So we decided to create automatic decision support system that will be allowed to measure and collect data and provide the information on the precision locations for the application of chemicals or the water for the additional irrigations. So the team which is involved in this experiment is me and Miroslav Konečný as a coordinators of the challenge and stakeholder engagement and communications with the participants. So if you will need any other information regarding this experiment or the Agrihub Czech and Slovak project, so feel free to write me. Then the database and data processing expert is Roman Danel, which will have also the presentation during this webinar. Michal Řepka, which is expert for image processing. And because the Agrihub use the GIS systems, so the Tomáš Peňaz is expert in this field. During our activities, we have several methods that were discussed. One of them was if we need to create the database of reference images, or we will use the vegetation indexes and DVI or EVI. So the data and equipment list that we discussed, it was the LPIS data, which is open database in Slovakia, which offers some GIS data, weather data from satellite like Sentinel, Landsat, and Spot, data from drones, and also the training data set for classification algorithm and real data from field with the disease and bugs, which are linked with the basis of references images of plants in different phases of vegetation process or different type of disease and bugs on each type of the plant. Then we set our objectives or our aim to develop the information system to support decision making in the field of automated assessment, measure and collect the data for the purposes of the precision applications of the chemicals. And we decided to use the methodology for identifying problematic areas of the selected crops based on the vegetation indexes. It's previously mentioned NDVI or the EVI indexes. After INSPIRE Hackathon, which was held during the autumn 2021, we also highlight some steps that are very closely linked with the using of drones in agriculture and in the field of health states of the plants identification. So it means that we found that the possibilities for future development and implementation in the agricultural practices are very wide for this field of experiments. And also there is a big space for the future cooperation in the frame of the triple helix principle. So it means research and development, farmers, and also the business companies that can find new opportunities for the business plans in this field. But we have to open the discussion with the farmers and the primary producers in the rural sector about their exact requirements for these services, and also about the effect of the local climate conditions. If the using, for example, drones can bring some additional positive impact on the local environment, for example, in comparison with some mobile robots or some other agricultural equipments. So this is all from my side, and as I mentioned at the beginning, if you have any questions, not only during this webinar, which, as Marketa mentioned, can be right directly in the chat, or you can use my email to stay in contact. Thank you very much, and the market card floor is yours.
Thank you, Zuzana. Thank you for your presentation. So are there any questions from our audience? Okay, one question came from the audience, is written in the chat. Is there a real interest of farmers to use drones for the health and nutritional conditions of crops diagnosis, considering the limitations for using drones?
This is a really interesting question, because we have to consider the two types of farmers. The small farmers, which are acting mostly as family farmers, they in general try to avoid the high technologies or innovative technologies. But if we consider the large farmers, which are biggest part, for example, here in Slovakia, they really have interest to use innovative technologies, drones, but also this is very good or very big interest between the companies, as I mentioned. They first of all have interest to start the business in this field, but they have to find the way how to provide it. So if it will be the business to service or some other kind of services.
Okay, thank you. We have another question from Christoph Ramshorn. Which weather data are you using?
Honestly, this is not a very good question for me, because I am not a technical expert, but maybe Roman Daniel will be able to answer, or if no, we can write the questions after the answer after the webinar.
Okay, so thank you, Zuzana.
Thank you very much.
And let's continue with the second part of our webinar, where you will learn about the practical use of drones in agriculture. Let me introduce to you Dr. Patrik Kosa from the Slovak University of Agriculture, whose research is focused on the design and automation of different kinds of measurement system and machines in practice. So Patrik, the floor is yours.
Thank you very much for the introduction. So I will start with my presentation. I hope that you will see my screen. Here it is. Okay, I hope that you will see it as I see it.
I'm sorry, it's not in a presenting mode.
Oh, sorry. I will try to adjust it a little bit. Now you see it?
No, you can stop sharing, press the F5 and then share one more time.
Okay, I will try once again. Share screen.
Yes.
Is it better?
Yes.
Okay. So my name is Dr. Patrik Kosa. I am from the Slovak University of Agriculture in Nitra, and my presentation will be about farming robots and the use of drones in agriculture. In the beginning, I will start with the application of robots in agriculture. I will mention some special kinds of these robots, how they work and what are they used for. Then I will continue with the specific category of these robots, and these will be the drones that are used in the agriculture. And then I will finish with a more specific field of the use of drones, and it will be the possibilities of gas sensing by drones in the field of agriculture. In the beginning, nowadays, this topic is very popular because every kind of farm and nearly every company is have the interest to automate some kind of specific job that are used to be done manually these days. And this is the field where also the agriculture comes in. So the farmers used to use several manual or half automatic systems that are used to control or to seed, crop, move the land, and so on. And nowadays, when the topic of robotics is introducing and increasing every day, they are finding new methods how to use these new technologies to implement them into their work and how to automate some kind of different and very nearly boring tasks that took too much time to do them. There are also several dangerous and repetitive tasks that have to be done nowadays manually or by very specific machines. And also there is a high risk that there will be some injury to the user or to everybody that is near these machines. And also the field of robotics tries to replace some conventional techniques to more automated and specific ones. Here comes the term in precision agriculture that is also a little bit connected with this way of robotization and automation, where farmers are nowadays using several types of precision agriculture methods, but very high amount of them is not automated, or they are not using specialized robots. They are only using specified systems that are able to precisely crop or do some kind of very difficult task. So when we are talking about these conventional and automated techniques, we know nowadays that these conventional techniques depends mostly on human power, but robots that are used in this field can work non-stop. And on the other hand, humans need to rest and also take care about their health when they are working with some herbicides or fertilizers and so on. Because in the field of agriculture, the farmers are using a lot of chemicals to protect their plants against some diseases and so on. Also, the other advantage of the use of robots in this field is that they can be programmed or used to detect the presence of diseases, weeds, insects, and other stresses. This is also connected to the field of image processing, and we will talk about it later. And also these small robots are lightweight, and so they do not compact the soil as much as the tractors on the on the field. And at least there is the possibility to remote control these robots, and they can be used to, for example, to monitor the livestock on the fields. We have several types of these agricultural robots. At first, the most basic ones are the stationary robots that are mostly robotic arms or some unique automated mechanism that are used for one exact thing or process. Then we have the basic land robots that are wheeled or track robots that are able to harvest, spray, or to tow some kind of machine. And then we have walking or crawling robots. You can see in my presentation in the right corner a very special robot called the Humble Hamster. I have found only a little bit information about it. It is a robot that is controlling the compaction of the soil, and it is measuring the way of compaction by its by the torque that is used to move that kind of ball on the soil. And that last not least, we have aerial robots, UAVs, unmanned aerial vehicles. And here we have aeroplanes, drones, airships, and some other types of robots that are used to automate some kind of specialized task. As I have mentioned, there are very high amount of tasks that are used to be automated by these kinds of robots. We have automated harvesting systems. We have many tractor robots, robots for weed control, for moving, pruning, seeding, spraying, and thinning, for row crop, and so much other, so high amount of agricultural robot platforms. And now I will continue with a specific field that is connected to the UAVs and so-called drones. And this field is based on, for example, the aerial spraying, cropping, and sensing by the drones themselves. So the drone is also called as an eye in the sky for agriculture. Here in this table, you can see that the drone has several usements in the year. So, for example, in the spring, when the machinery is prepared, the fertilizers are applied, and so on, the drones are used to analyze the soil and to find out and exactly tell when and where you have to use the fertilizers, herbicides, and so on. Then in the summer, when also all the chemicals are applied and the irrigation is managed, the drone can tell the user where to irrigate, when to apply the herbicide, fertilizers, and so on, and also to find out the properties of these plants by the cameras that are on the drone. In the fall, the drones are discovering the possibilities when to harvest and what is the exact state of the plants on the soil, and to find out when to apply any other chemicals, or where to harvest the crop. And in the winter, the drones are mostly used to just to find out if everything is okay, or the user is analyzing the data which was taken by the drone for the whole year. So when we are talking about the soil and field analysis, you can see that this area is connected to the image processing. So by some kind of thermal imaging techniques, we can produce some images that are based, that are telling us how does the soil look like.
No sound to listen anything.
Sorry. Okay, I will continue. By the field analysis, you can also do some kind of seed planting patterns and so on, and also to analyze the environment and the soil by the taken images and videos. And I will continue with the crop and the health monitoring. My colleague Zuzana has also talked about this problematic, and this is connected to the NDVI index. It's so-called the normalized difference vegetation index. When the drones are fitted with infrared, multispectral, and hyperspectral sensors that are able to sense the color of the leaves and the plants, and by their specialized code and these indexes, where is the mostly used index, the NER index, is used to find out if the leaf is healthy or it is stressed or dead. You can see in the pictures how does it look like, and we can use this technology to find out if everything is okay, and also to count the possible losses of the leaves and the plants. Then I will continue with crop spraying. This is also a widely used technology when the soil is scanned by ultrasonic, infrared, or LiDAR sensors, and then there is done a nitrogen absorption analysis by multispectral cameras, and after that the drones are spraying the exact amount of pesticides, herbicides, and so on. And this type of machinery is usually five times faster than when it is done by traditional machinery. Also, the drone is able to carry about 5, 10, or max 20 liters of these chemicals or mixture. So it is used only when you have to find out an exact place and to apply the chemicals on an exact places. So you are not doing a whole spraying on the field, but only on the exact places which were took and find out by the optical sensing systems. Then I will introduce a very interesting field of the use of drones, and this is aerial planting. This method reduces the labor cost of the associated method by approximately 85%, and the uptake rate is raised by approximately 75%. The technology is based on the shooting of pods with seeds and plant nutrients into the soil. So the plant had received in this small container everything that it needs to start growing and to survive in the specialized conditions. And I will continue with maybe the mostly used technology that are the drones used for, and this is livestock monitoring. So the drones are equipped with standard cameras or with thermal cameras, and the users are used to monitor their livestock on the fields to see if there are any injured, missing, or birthing animals, and to find out their exact position. It is a very cheap and effective way of feedback for these kind of farmers. And in the end, I will finish with the field of gas detection in the agriculture. This is the field I'm used to work on. So this topic is very interesting because nowadays in the agriculture there are so many places and environments when there is the possibility of to be hazardous, because there are some very hazardous gases, elements, and some leaks, for example methane, that are very hazardous for the users and for the farmers themselves. So in the practice, the mostly the detection is mainly done by some kind of static sensing systems, but nowadays when you have to deal with some kind of problem, it is an advantage to use this type of system, because it's remotely controlled and you are protected from this type of gas. There are nowadays several systems on the market that are able to sense specific gases in the environment, but these systems are used to sense only 1, 2, or 3 types of gases, and this sensing system is mostly based on a very expensive system that is based on a optical sensor that uses, for example, infrared spectroscopy that is able to sense only a few types of gases, and it is very expensive. So in my research, I am dealing with these problematics, and I am trying to find a way how to solve this problem and how to find out and discover more methods that will be able to sense these gases and to sense also more gases more accurately on the drones, because there are also other sensors that are used to sense these special gases, but they are based on some thermal sensing or electrochemical sensing. And the main problem is that when they are in an environment where the speed, where the wind speed is too high, they are not able to sense this concentration of gas very accurately. So thank you for your attention. If you have any question, feel free to ask me or write me an email and so on. And I will give my word back to Markéta Kolerová. So thank you everybody for watching.
Thank you, Patrick. It was a very nice presentation. We have some questions from the audience here in chat. So Teresa is asking, what do you use to process the images and what kind of software do you use?
As I have mentioned, I'm not dealing with this type of problematics, but as I know that there are specialized systems and algorithms that are able to process the image, the wavelength, and so on. But at this time, I am not able to tell you about this more because I am interested in only the gas sensing methods in the practice. But thank you for the question. It's a very good question.
Okay, so let's get back to gases. We have a question from Christoph Ramshorn. Does turbulence from the rotors affect the detection of gases?
Yes, it affects the measured concentration a lot. I have also done research studies, and I have compared my data with the data from another researchers, and it is a very big problem to find out the best way how to measure this, because the data from me and other researchers shows that there are, for example, in some kind of gases and special situations, a nearly 80% difference of the measured concentration against the static state concentration. And I'm also working on several simulations where I am trying to find the best way and where to sense the gas on the drone. And the simulations are showing also from my colleagues that the best way is to measure at first on the top of the drone, and the second method is under the drone, but too far from the drone, not on the drone. I hope I have answered everything that you wanted to hear.
We have another, okay, this is not a question for you, but there is a new one. How can we apply the deep learning or neural networks for UAV usage in agriculture?
Oh, that's a nice question. At first, you have to find out the exact algorithm you want to use for the exact process, because this is not an easy task. Because to control a drone, it is not only about the user, but also there are some very specific conditions. For example, the speed of the wind, and also any other conditions that are affecting the at first the control of the drone, and second to collect the data. because this type of and image processing and every kind of processing we are using in this topic is connected to other professions when they have to find out exact ways how to process the data in a static state, because it is very complicated. Because, for example, the control of the health of the leaves, it's a very complicated state, because in every kind of and type of vegetation, in every different time, it has different colors, different possibilities how to grow. It can be affected by diseases and so on. So for these topics, there are usually teams of a lot of researchers that are dealing with an exact problem, and it takes a lot of time to find out if they are able to use some kind of neuron control system and so on. But at this moment, I am not able to tell you how it is exactly done. I only know that also some of my colleagues are dealing with these problems, and it is a very time-consuming method and work.
Sorry, maybe I can add some information to this question, because previous question was about process how to process imaging taken from drones. It's not my field of professional expertise, but my colleague Dr. Michal Řepka is a specialist on image processing, and as I noticed, he used several tools, but also he is a good programmer, so he did some tools by himself, and one of the tool used artificial intelligence and neural networks with combination with hack transformation. Hack transformation he used for detection of objects, and neural networks for classification of colors, and these tools is able to identify color objects. So if someone is more interested in this area, I can give you contact to my colleague. He unfortunately today is not able to join us, but I am sure that he will answer this question professionally.
Okay, thank you. So I know that there is another question in chat, but we will keep that after your presentation. So now I think we can move on to you, Dr. Roman Danel, with the last part of today's presentation. You focus your research interest on information systems and automatic control in industry, databases, software engineering, and business information systems. So now you can take the floor, and we will see your presentation. Thank you.
Thank you. So to my presentation. So I hope that you see my presentation.
Yes. Yes.
Okay, thank you. So good morning. And in the last presentation of today's webinar, I will continue with my presentation to the ideas presented by previous speaker. And I want in my presentation talk about what we can do with drones in the area of agriculture, and generally identify something on landscape. I want to present a case study, project Invaro, that I was participating on in the past, and on this project drones was used. And the key idea of my key topic of my presentation is to identify what students should know or learn to be able to use the drones on their work. And I focus on students of non-IT disciplines, so students that study some study program in agriculture or environmental engineering. And at the end, short notice about one methods that has been developed on University in Ostrava. As was mentioned, I am cooperating with 3 universities. The main one is Vysoká škola technicko-ekonomická České Budějovice, second one Technical University in Ostrava, and also a bit with Poland universities. And professionally, I am someone who is focused on IT technologies, on databases, some, data analysis, operating systems, and programming. But everything that is done with drones sooner or later is connected with IT. So this task is not possible to do with IT support. But at the beginning, I want to present some activities that is possible to do using drones. And maybe you noticed that my previous speaker also present some areas of drone usage. So this is an addition to this areas. So for example, there is possible to detect insufficient irrigation because it's the result of this is to change color of leaves and color of the area that we can identify by drone images. We also can identify some plant diseases and pests. And for this will be the best solution to have some expert system that contains reference databases of known plant diseases, and we can compare picture taken from drones with this picture in databases, and it is possible to develop some automated system that could do evaluation of these pictures and identify if there are some diseases. So this is one task that could be developed, and maybe within this hackathon we can focus on this area. Another thing is analyzing condition of treetops, because this is a place that is not visible from the ground. So, drones could do this task, or searching some stripe of soil or rock that could affect the plants on the ground and cause that the production is lower in this place. So I know about some application here in Czechia that was focused on this task. Also, we can detect some damage of amelioration system. As Dr. Kosa mentioned, for spraying of the plants, and for example, analysis of invasive plants. I will talk about this later in my case study. So there is a lot of tasks that could be done with the help of drones, and comparing with aerial photos, there is some advantages and disadvantages. Advantages I can emphasize is that it is faster and cheaper than aerial photography. On the other hand, it's limited by a range of area that is that we can detect by drones. So in some cases, aerial photography still could be more efficient. So it's not always that in all cases drones are better. So what I want to present in more details is a project INVARO that I was participating on. This project was international project with realized as a cross-border cooperation between Czech and Polish subject was realized in 2016 to 2019, so for 3 years. In Czech side, there was involved Technical University in Ostrava, in Polish Geological Institute in Katowice, and the key focus of this project was working with invasive plants. And the idea was that there is a directive of European Union that recommend for municipalities some activities that they should do to prevent spreading this unwanted invasive plants. So within this project, we developed methods of risk assessment, and the key output was to describe a strategy and plan how to reduce the risk that is connected with invasive plant species. And one of the particular tasks was to analyze this detection of the invasive plants and analyze this rate of spread of these plants. And for this task was used the drones. So within 3 years, we took a picture from the same places and we analyze this. How fast the invasive plants are able to spread, and according this, because it's different for different species, we specify which procedure municipalities should apply to stop spreading or remove these plants, because some of the plants are very aggressive and would be dangerous for human. For example, this plant on this picture contains some liquid that could injure humans. So it's a really unwanted one. I do apologize. I don't know English name of this plant. In Czech, it's bolshevnik. So this is a drone that was used on this task. And this is an example how it worked. This is one of the invasion plant called Netikavka, and this is an example how it looks on drone images. This is in this yellow object is area that is completely covered by this plant, so we can see that this field could be bigger if this area it's about 20-30 meters that was completely damaged by this plant. And what I should emphasize here that this images later was connected with using GIS system with some map background. So we were able to present where this area are located. And as I mentioned, within 3 years, we can analyze the rate of spreading of these plants. And what is also important, all these analysis has been done manually. So still it was about this, that some expert on this system do this by his hand within a computer. So of course, in the future will be a very good solution if this analysis and detection and evaluation, and especially this evaluation in a time series of the images will be processed automatically by some expert system using this technology that I mentioned at the beginning, some neural networks for automatic analysis of these areas. There's another example of spreading some invasive plants. We can see that here is quite a huge area affected by zlatobil, and this is this Heracleum, this Bolshevnik, very dangerous and very difficult for removing plants. So again, in this picture taken from drone, we identify some places where this plant is spread. Just a curiosity, this plant is not possible easily remove, because the worst thing that you do is cut this plant. It causes the faster spread of this, so it must be injected by poison every particular plant. So it's a really difficult task. And this is an example of long-term evaluation. So this is several layers of picture taken from drones in the same place within a longer time period, and we can analyze and study how the plants are spreading and how fast they are do this. So this was one of the important output in this project environment that we realize. So what we used on this project, of course, drone images, but later we joined these images with GIS system. Colleague used ArcGIS, and use another data sources like vector data from Zabaget. It's a public database of maps that is possible to take for area of Czech Republic. I should note here that this service is for payment. So if you want to use a map with very deep details, you have to pay for this. And this is problem of several public available data that for free is limited access to these services, or data are not in deep solutions. So if someone wants to use these public sources, also this raster maps is taken from public sources, every this data are for payment. We also use elevation data from Zabaget and also cadastral data. Cadastral data were for free in this time, but quite recently they also changed policy, and also it's nowadays accessible for payment. So based on this case study, I start thinking, because we involved some students on this project, and this was a student of environmental engineering, so students that are not focused on IT technology, but the students had to learn some IT technologies to be able to evaluate this picture. So based on this, and that we used some public data sources, later we analyze which data sources are available in in Czechia. So on this slide is a list the most interesting ones that we can use. So the most important is, of course, this database of maps that offers very deep deep details in resolution of objects. But also there is a database of forest provided by Lesy Česká republika. It's the biggest state company that manage all forest in Czechia. And there is a databases of forest, including maps, including what plants there are in these areas, and geological and weather condition. Also, there is a database of protected areas. There is some ecological data, hydrogeological data, climatic water management data, of course, data about weather. Maybe answer to the question at the beginning, what weather data use. It depends on task that we solved, because on some task is enough to public available data, but if we want to analyze professionally some areas, and especially in a large time period, it is a good idea to use some professional service. For example, recently we discussed with service called MeteoBlue. It's a worldwide service. Of course, again, these data are for payment. So it depends on what task we solve, and if we have enough money for buying a lot of data from these services. For example, this MeteoBlue offers very interesting data. For example, how weather are changing within 20 years on every place on the world. So it's quite interesting for agriculture, because you can study how weather can affect this area. So to do some professional analysis on some areas, it's necessary to know which data are available, from public sources, which data are available for free, or if it is for payment, and how much does it cost, and what conditions are for using this data. So based on this, I try to formulate what students should of non-IT study program should know to be able working with drones images. And there are several competencies that they should have. And basically, it's about knowledge of technology. So there is no necessary to know how this technology inside is working. It's IT things, and it's not interesting for a user. But they should know how this tool works, and what is necessary to process the images to obtain some interesting result for the field of specialization. So basically, they should have some knowledge of this system, understand how it's possible to working with layers, and how is possible to combine data taken from these different data sources. Because it's, for example, task that was crucial in this Enviro project to join this this drone picture within some maps taken from public sources to identify where these invasive plants are located. Again, also students should know what public data are available for landscape analysis. As I mentioned in this slide, this is for Czech Republic, and it's quite different from Slovakia. It's different from Poland. So in every countries there is different sources. Recently, European Union do some activity that want to unify the sources that are available, especially in environmental area. But still, it could be different and could be different condition to obtain the data. Students should also know a bit which information systems are available and which of them are offers some public data that are useful in agriculture, and should be familiar with some methods and methodology how we can process the images. It's more about using of tools, not about analysis deeply IT technologies. So the question in previous presentation, what tools are used for images, for analysis of the images. This is a question that IT people should prepare these tools with a methodology how to use these tools. So this is our task to provide this for students and for other professionals that work in this area. And students should know what for what drones are suitable and for and when is not good idea to use drones. And this is about knowledge which technical limitations are connected with drones usage, in which situation is better to use aerial photography. For example, when we want to analyze wide area size, it's probably better solution. And also there's some restrictions done by legislation. So it's not only about technical usage, it's a more complex task. So it's a combination of several technologies and a combination with legislations that could limit it some usage. In this slide, I want to present some examples of information systems in Czechia. There is, for example, public available land register or livestock register. So is when Dr. Kosa mentioned this identification of animal by thermocamera from drones. I can imagine that it could be in some way connected with this livestock register, maybe with using some other technologies like RFID. We can by drone identify the animal and connect it to this database. We can pick up more data about this. So again, this is a task for future. There is a information system for water situation, some information that is focused on logistics of food products. So also this is an area that students should be familiar with. And the last one on my presentation is that I want to present some methodology that has been already developed in Ostrava, in Technical University in Ostrava by docent Neustupa. It wasn't focused on agriculture, but it was produced for environmental engineering, because in Ostrava there is a huge area that is heavily affected by mining. So the aim of this methodology was to be able take data from different data sources and using process this data with several tools, and the main output is a visualization of this landscape. and the possibility to modeling how this landscape will be look after applying some revitalization methods, for example. So it's a very useful tool for planning. On this scheme, we can see that is a combination of GIS system. Concretely, it is ArcGIS with CAD system, AutoCAD. And the final step is software 3ds Max that allow to produce some visualization. So maybe on this slide it's more visible that at the beginning is GIS system. And what I want to emphasize, this method has been developed 10 years ago. But now we are thinking about a new version of this system that support images taken from drones that could be do very fast in some limited area, and it could help how fast this visualization could be done, because originally it was based on aerial photos that are quite static. So process data within these several tools. At the end, there is a visualization that could be interesting for some managers that want to decide how this landscape will be used in the future. Of course, some of this landscape that was destroyed by mining in the future again will be used in agriculture. So there is an example of landscape modeling taken from Orlova mine Lazy. So this is an aerial picture, and this is this that we want in the future replaced by a picture taken from drone with high resolution, transferred to the GIS system, connected with map taken from public source, and we are able to do visualization of this landscape and also modeling of the landscape. So there is a possible to set some parameters and present how this landscape will be looked after applying some recultivation activity. So this is what I want to present for you. I have no idea, no task to specify no new study program with competencies of students, but I want to pick up some knowledge that students should know to be able to work with drones. So thank you.
Thank you, Roman. It was a very vivid presentation. We have a very last question here because our time is almost up. So please be brief with your answer. Does every drone task need to be controlled by a person in real time, or can some of the tasks be automated without the need of human interaction?
If it's about taking picture from drones, it's probably should be done by a human operator. But the processing of this data could be done with some automation process, and this is one of the tasks of this hackathon, to analyze possibilities and to develop some tools that help this task, to avoid manually analysis that is really time consuming.
Okay, thank you. We have another one. Is it possible to know in which rural sectors are more used the UAV in the Czech Republic? For example, in Valle de Cauca, Colombia, most of the use of the aircrafts are in sugarcane crops. It is difficult to find this information on the web.
Yeah, is the same in Czechia. It is difficult to find any information. And as Professor Palkova said at the beginning of this webinar, it's a different for small farmers and different from big one. So in small farms, there is a lack of interest to use drones because they solve different problems. and which rural sectors. Mostly it's focused on irrigations, so detection some areas that that there is a low moisture and it affects the production. I don't know if they are used for some disease detection. I think it's in the beginning. So it's another task that this hackathon and this group of people could solve, because there is a missing database of reference picture that we can, because it's about how we can detect this disease, how we can distinguish that this is a disease and not lack of moisture or another, or there is a big influence of seasons. So it's different color in spring, in fall. So we should eliminate all these influences, and the best solution will be that there will exist some database of referential pictures, and at this moment it is possible to do some automatization of this evaluation.
Okay, thank you. And the very last question: is it possible to use it in Zambia, and how effective are they in small-scale farmers compared with costs?
Yeah, cost is a problem because some of this there are several problems. First is legislative, if it's allowed to fly by drones, because, for example, in Czechia is not allowed use drones outside the buildings. So it's necessary to fulfill these requirements. Second one is that in a bigger one there is a need to driving license. And third one is that the costs of high resolution multispectral camera is quite big. It could be around 10,000 euros. So it's not cheap equipment. So it depends that if you want to use this for solve something, you have to calculate if it's financially in good state, because is quite big investment, and you should think, what do you want to achieve by this? What do you want to detect? And will this investment come back in some time period? It's a question. But technically, it's possible to use it everywhere. I think technically it's not a problem.
Okay, thank you. So our time is really up. So I would like to thank to our presenters, Zuzana Palková, Patrik Koša, and Roman Daniel, for their presentations. It was a very good webinar, I think. Also, many thanks to our team in Plan for All for your support. And of course, thank you, our audience, for your time. We hope that you enjoyed the webinar. And if you have any questions, do not hesitate to contact us. If you have any other questions to our speakers, we can, of course, share their contact details, and yeah, you can keep in touch. So I hope to see you soon at the next webinar, which is planned for Friday, 20th of May, or again at 10 a.m. And this webinar will be focused on precision farming. So again, thank you and see you soon.
Thank you, Marketa.
Thank you, Marketa, and thank you all to join to us.
Good presentation. Nice to hear you from Bujumbura.
Thank you, Anton.
Thank you.
Thank you.